So, how to compare the graph of each function with a graph of f(x) equals x to the second power. So, we're going to compare g x equals 5x to the second power plus 3 and fx equals x to the second power. So as we can see here, since 5x or 5x is less than the invisible one here, the graph of the 6x equals to 5x to the second power plus 3 is narrower than fx equals x to the second power. Second one is, since we can see that this 5x to the second power and x to the second power are both positive, then we must know that they are going to be, the answer will be going to be downwards or a happy face like this. The next one is, since if we apply the form negative b over 2 times a, if we apply this in this equation, it will be going to be 0 because there's no other number here and there's no value of the x here. So So as a result, these both functions have the same axis of symmetry, which is 0. So the last one, or no, not the last one, but the next one is the vertex. So the vertex of fx equals to x to the second power is 0 and 0 because there's no any value here. And while the vertex of gx equals 5x to the second power plus 3 is translated 3 units up because we can see that if we block this number, we can only see 3. Can only see 3, and so that is the vertex. So today we're going to solve each equation by graphing the related function. The equation that I chose was x2 plus 3x minus 4 equals 0. So the first thing we're going to do here is to rearrange this equation into the form of y equals ax to the second power plus bx plus c. So the 0 will be standing for the y, so y. The ax2, as we can see, it is the same as the x2, so we're going to have x2 plus, because it's also addition, and then the bx is 3x because they're the same, and then the last one is the only number, so we're going to write this one, the last one, negative 4. So after rearranging, the first thing we're going to do to graph the function is to find first the axis of symmetry by the form of x equals to negative b over 2 times a. So we're going to substitute them. The negative b or the b will be going to be the 3x or the 3. We're going to get 3 over 2 times the visible one. Then after that, we're going to rewrite it first. Negative times 3 is negative 3. 2 times 1 is 2. And so we're going to divide them. Negative 3 divide 2, it will be going to be negative 1.5. After getting the axis of symmetry, we're just going to get, or after that, we're going to get the vertex. How to get it? So we're just going to substitute the axis of symmetry to the x of the form of the equation that I wrote or that I typed earlier. So y equals to negative 1.5 to the second power plus 3 times negative 1.5 minus 4. So negative 1.5 times negative 1.5, it will be going to be a positive 2.25. And then plus the 3 times negative 1.5, and it will be going to be, I'm sorry, it's not supposed to be addition, it was supposed to be subtraction. So the answer will be negative 4.5 minus 4. So we're just going to keep 2.25, and then we're going to add the 4.5 and 4 because they have both negative sign. So we're just going to copy the sign. Then 4.5 plus 4, it will be going to be 8.5. Then after that, we're just going to subtract them. And so we got the negative sign because it has the larger number and then negative, and then we subtract them. 2 times 2.25 minus 8.5 will be going to be negative 6.25. And so we know that negative 1.5 or 1.5 and negative 6.25 is the vertex. And so we're just going to get the y-intercept. The y-intercept. So as we can see in the equation earlier, we see the only number, and that is 4 or negative 4. And so y-intercept, and then we're just going to have a 0. So that's the y-intercept. And then after that, and then we're just going to get another point. So the another point was we can use any number. So we can use 0 and negative 4, 2, and 1 and 0. So these are the two other points, or we can just cross this out because there's already here. So we can have 1 and 0. And so after getting all the points, we're going to graph it now. So we're gonna write first the axis of symmetry. So the axis of symmetry is 1 or negative 1.5, and the vertex is negative 1.5. Oops. and negative 6.25. That's 25. And then we're going to write y-intercept. So the y-intercept is 0 and negative 4. And then the two other points was 1 and 0, or the 0 and the negative 4. So we're going to graph it. So the axis of symmetry is negative 1.5. So we're going to draw a line here. Ooh. And then the vertex was 1.5. So here negative 1.5. Then we're going down because it's negative 6.5. Negative 6.5. So we're going here. Ooh. Whoops. And the y-intercept is 0 and the negative 4. So here 0 and the negative 4. And then the other points was 1, positive 1 and 0. So we're going to stay here. And we're just going to reflect them. Then here. And then here. And then we're just going to graph. Oops, bad. Like that. And so we can see this is a happy face or a downward parabola. So you can see the equation is positive, so it's correct. We can see that it is going down. And that's how we graph or we solve a function and graph